a lot of this stuff is stored as vectors in a vector database, right? So let's take a little diversion down into that. Like when I first started learning about ChatGPT and then, technologies like LangChain came out, I started building my own stuff, and 9 times out of 10, the examples on the web were using Pinecone. And I was like, oh, what is this Pinecone thing? Let me go learn a vector database. I'm like, well, Elastic has a vector database. Why can't I just use Elastic? What is the answer to that question? Like, can I just use Elastic for this with something like LangChain? Let's talk about that, and then we'll come back up to the surface and maybe answer the broader question.
Yeah, the answer is you absolutely can. So Elasticsearch's vector database is highly capable. We built it directly into Lucene, which has some enormous advantages, as being the core relevance engine of Elasticsearch when it comes to things like filtering, which we touched on. Actually, we have a way of being able to do that that's actually pretty unique because of the way we built our vector search algorithm. But we actually even go a step further than what the vast majority of vector databases do, including Pinecone. So like a typical vector database, at least today, they are again a point solution. You get your vectors somehow, and like the typical process that you're describing is you take plain text, the document that's in a PDF or on your wiki or something, and you pass it through a transformer model, and out comes an embedding or a dense vector, right? That's the output, and then that's what you store in your vector database. But most of the vector database vendors, they're just the storage engine for the vectors. They don't participate in helping you create them. So they expect you to either create those using third-party software or a third-party API like OpenAI's. They have an embedding API. At Elasticsearch, you can just put a transformer model for doing embedding in the ingest pipeline. So you could say, when I send Elasticsearch plain text, pass it through this embedding model, and when the dense vector comes out the other end, store that in the vector database, but also store the plain text in our inverted index in the BM25 stuff. So we've pulled together a whole lot of that. And I think that the interesting part of what we're seeing, and I think you're seeing it emerge in the overall ecosystem, partially actually, I had the pleasure of meeting the folks over at LangChain who are great, and they're doing really interesting work. We have an integration with them now as one of the retrieval backends for Elasticsearch. And part of that is because people are realizing that dense vector retrieval on its own, where you're just using vectors to do that retrieval rather than using the kind of more traditional like keyword or lexical matching, it doesn't work that well in many cases because most embedding models are trained on a domain of text. So it'll be trained on maybe pharmaceutical data, and it's really good at creating embeddings for any kind of data that comes in that's pharmaceutical data. Or maybe there's a different model that's really good at financial data because it learns those vocabularies and things like that. But if you use it to do retrieval on any data outside of that domain, it actually is like kind of nonsense. It doesn't work very well at all. It works way, way worse than if you just put some keywords in there and hoped for the best. And so what we're finding is that in a lot of the academic research is coming out, the best performing models are a combination of the two. So you actually want both. And then there's a whole other category of things. Probably one of the more exciting things that we worked on or that we released as part of Esri was a proprietary model that we built. It's an out-of-domain model that's meant to be used on, it's trained to work generically on any kind of text you throw at it. It doesn't have to be trained on a particular domain. It's a transformer model, but it's a different type of transformer model called a late interaction model. And it's really quite innovative. There are a couple of other ones out there that have been published, but Elastic has a really good one. And it's the kind of thing that we have to, if we're going to ship a model with Elasticsearch, obviously we wouldn't ship a model that only works on financial data because we have customers that use us for everything. So we had to aim at something that we could reliably feel like we were going to give our customers the ability to, get retrieval, like high quality relevance out of anything they throw at this model. And so that was one of probably the third big pillar of the Esri launch was the first release of our proprietary model, which is nicknamed ELSA. It's a Elastic's learned sparse encoder model. So it's a really interesting thing.
So Matt, with that one, you're saying that if I have that, I don't need ChatGPT if I don't want to use it. I don't need OpenAI. I don't need Llama, and I can still have a pretty good experience.
Well, so this particular model is actually more a replacement for the embedding process for creating vectors, right? So
gotcha. Okay.
When you're in the side,
it's like the intermediary.
Yeah, so when I was describing retrieval augmented generation, there's this process of like finding the most relevant document and then passing that over to the LLM with the original question. How you find that most relevant document is up to you. And it's, at least inside of Elasticsearch, you could use our BM25 algorithm, which has been around forever since the very first version. You can use dense vector retrieval using our vector search database and using a specific dense embedding model, like we were talking about. But those have the downside of, if they're not trained on the same data you're embedding, they can create embeddings that don't really work. Or you can use something like ELSA, which is something that's meant to be an out-of-domain retrieval model and still provides kind of what the promise of all, the reason everyone got so excited about vector databases and dense vector embeddings is because they can understand semantics better than keyword matching. And so it kind of combines, it has the capabilities of understanding semantics, but it doesn't have to be trained on a specific kind of corpus or vocabulary of data in the same way. But in the end, those are all three ways of just finding the most relevant document or two to pass along to something like Llama or ChatGPT or whatever.